with that, I'll go ahead and introduce Sean, who is our speaker today. Sean is, I've known Sean since he joined NepRWA, the Neponset River Watershed Association, back in the end of 2021. Sean leads the restoration and scientific programs at NepRWA, and he has a background in restoration work with a PhD in environmental biology from UMass Boston. So I want to thank Sean for all the work he's done in helping our Embrace the Stream program for the last 2 years, and really looking forward to the results. So I'm going to stop sharing, Sean, and let you take over.
Yeah, this Mike. Let me see. Let's go. So thanks, Mike. Thanks everyone for joining. I know it's easy to join on Zoom, relatively speaking, but I think we'd all rather be at Patagonia, Boston. But maybe in the future. So as Mike said, I'm going to talk a little bit about our latest 2-year study, which we call Embrace the Stream, and looking at the urban threats to trout in our watershed. Sorry, I'm going to hide my little. Are people able to see my screen?
Yep.
Okay. And just to kick off, for those who don't know the Neponset River Watershed Association, as Mike said, I'm the River Restoration Director. And we are an environmental nonprofit. We're a watershed-based nonprofit, so we're concerned with all things the Neponset River and its tributaries and its watershed lands, roughly 120 square miles from Foxborough up to Boston. We are committed to improving water quality, climate resilience, access to the river, access to green space, education. So we talk to 5th grade students about stormwater and water conservation, and kind of talk to people about how they can make a difference, protect their environment, enjoy their environment, and advocate for cities and towns and the state to improve the protection and conservation of the lands we have. And this is something I probably don't need to tell this group if this is how you're choosing to spend your Monday evening, but in case you were curious as to why we should care about brook trout. So brook trout are a native species to Massachusetts. They were once widespread across the state. And if you look at this map from Eastern Brook Trout Joint Venture, you can see a lot of red on this map, and this is all areas where brook trout populations have been in decline, or in gray where they've been driven locally extinct. There's not a lot of green on this map, especially not in Massachusetts. So we've lost a lot of our historic populations of brook trout. A couple of different reasons for that. Historically, habitat loss and land use changes, as we've developed forested areas for agriculture or cities and towns. We've changed the way water moves across the landscape. There's a lot more impervious surfaces where water doesn't get into the groundwater. It collects a lot of pollutants. It collects a lot of heat, moves into our streams, and makes it hard for brook trout and other fish to survive. Connected to that, we've reshaped a lot of these streams. We've torn out woody debris. We've added a lot of sediment from just loose sediment getting into the streams, which can fill in gravel beds that trout rely on, and just make it difficult for them to persist. There's also a lot of connectivity issues. So Massachusetts is a state of dams. So more than 3,000 dams spread across the state, and those are just the ones that are big enough to be put into a database by the state. A lot of these are defunct. They serve no purpose. In addition to sitting on the landscape, warming water temperatures, bringing down oxygen levels, they make it hard for fish to move around. Most of them were not designed for fish passage in mind. And when you separate out different populations, you make them smaller and make them more at risk of dying out from a particularly bad summer or a couple of bad summers back to back. The bigger the population is, the more they can mix, the more resilient they'll be to that kind of year-to-year change. And then the big one that we talk about a lot in the modern day is climate change and temperature increases. So human activities across the globe and locally have raised temperatures. We're having hotter summers, we're having drier summers, and the rain we do get is falling in high amounts really fast, which means it's not those nice soaking rains that trickle into groundwater and restore aquifers. It's really quick, really fast. It flushes through and it's gone, which does not particularly help refill that groundwater or provide benefit to trout. And so we're kind of focused on the second one a little bit more, or sorry, this third one a little bit more as we talk about the rest of the presentation today, because it's what here in Eastern Mass is the one we can kind of focus on. I mean, they're all relevant, but it's the one we can kind of look at the most acutely as something that's actively ongoing as a threat to trout. And I'm going to see if this works just as a kind of sneak peek. We, as part of this program, this two-year study, we also developed a middle school curriculum, and our former environmental science fellow Paul has a little presentation on why we should care about brook trout, what it means to be an indicator species. And if you're gonna have to tell me if the audio is not coming through, because if not, we'll skip it and I'll put a link in the chat. But that would give Paul a chance to explain why you should care.
Welcome to Trout Brook in the Neponset River Watershed. I'm Paul Hambury, an environmental fellow at the Neponset River Watershed Association. We're here today at one of the best streams for brook trout in eastern Massachusetts to talk a little bit about why brook trout are known as an indicator species and how trout depend on many different things to go right to successfully survive here. First, brook trout need water that is cold. And what that means is water that typically stays below 20 degrees Celsius or about 70 degrees Fahrenheit. They also need clean water, free of pollution like road salts, car chemicals, and fertilizer. They also need water that stays relatively clear, with no dirt or other debris, so they can see and navigate these streams. Because brook trout need all these specific conditions to survive, they are known as an indicator species. And what that means is that they reflect the health of the environment they live in, and they're one of the first species impacted by changes to their ecosystem. In other words, the trout population will start to decline if the water temperature gets warmer, if the water becomes more polluted, or if the water becomes cloudier. They are also able to tell how other, less easily observable species are impacted. Think of brook trout like the canary in the coal mine. If we can keep them happy, other species will be too.
Brook trout also benefit from one more C, connected. Brook trout are highly mobile fish. In some areas, even swimming out to sea, part of their life cycle. They also need to find other trout to mate with, and the bigger the population, the more resilient it is to things like droughts, overfishing, or other impacts. Unfortunately, across a lot of the Northeast and our watershed, dams and undersized culverts get in the way of trout moving around and interbreeding. So removing or replacing these would help our fish out immensely. Here at Trout Brook, a small dam was approved in 2022 that has allowed the brook trout to move freely up and down the brook. In the Neponset Watershed, we're thrilled that Trout Brook has managed to keep its brook trout population strong, despite the changes that humans have made to the ecosystem. Although it might not look like it here, we're actually right in Greater Boston, Route 1 and I-95 just upstream. While a lot of that success has to do with residents, towns, and organizations like NepRWA, Greater Boston Trout Unlimited, working together to prioritize the health of the brook, it is also related to groundwater. Trout Brook has many small springs where cold groundwater can seep up into the stream, lowering the water temperature and creating cold pockets for trout to seek refuge on hot days. The biggest challenges that Trout Brook faces today is from climate change and overdevelopment. Shifting climate patterns means less rain in the summer, hotter days, and drought, which dries out those cold water springs. At the same time, new development in our watershed means fewer trees and more impervious surfaces, which carries hot polluted water into the brook. So, what can we do to protect streams like Trout Brook? We can conserve drinking water, which keeps cold groundwater flowing into the stream. We can promote green infrastructure, which catches pollutants and cools road runoff before it enters the brook. And we can remove outdated dams that disconnect fish populations. Brook trout are living on the edge in eastern Massachusetts, and it's up to us to ensure that they survive for future generations.
All right. Thanks for paying attention to that. That's part of our school curriculum, which I'll talk about in a bit. But it's been a really great opportunity to connect the science to what kids want to know and kind of tie it a little bit more into what's happening in the world. And speaking of what we already know, kind of the best way to start a project like this is to kind of ask ourselves, what do we already know about this system? So how do we go about looking at road crossings and their impact on trout if we don't know anything about the system already? So basically what we have is that Mass Wildlife maintains a list of what they call cold water fishery resources. These are water bodies and streams that have cold water fish, not necessarily trout, but cold water fish, but they don't necessarily meet DEP standards for cold water, which is based on temperature. So as crazy as it sounds, you can have a stream that is not considered cold water that has cold water fish. We're using this this Mass Wildlife designation to kind of target where we expect to find brook trout. And in fact, the Neponset Cold Water Fishery Resources, or CFRs, were investigated by NepRWA and GBTU for trout presence using eDNA testing in the first phase of our embraced stream work. So back in 2019 through 2021, we looked at water samples looking for environmental DNA, or like trace amounts of DNA, to give a sense of where trout are in our system. And what we found surprisingly is that although there are 7 cold water fishery resources across the watershed, the five that have brook trout tend to actually be in the relatively developed areas of the watershed rather than the more rural locations. So you can kind of see that here on the map, and I'm going to fly through the results of this prior study just to give a little bit of context before we get into the most recent study. But as you can see, here are these green circles for the presence of brook trout based on DNA. And what we see is Trout Hole Brook in Norwood, Pine Tree Brook up in Milton, Ponkapog in Canton, a little bit in Beaver Brook and Sharon are where we, and Germany Brook in Norwood and Westwood border are where we find our trout. But if you were just thinking based on how rural is it, what's the lowest development area, Tubrek Brook and Mill Mine Brooks out in Dover and Medfield would be the one that you'd think. So it is surprising that we find so many trout, so many rich trout populations in and near our urban centers, which is great because it means that more residents can get to a trout stream quickly. But the flip side of that is they're more at risk, and we need to do more to protect them. So that's kind of what we found from where we find trout in our watershed. The other part of the first phase of Embrace Stream was to look at barriers to their passage. So looking at culverts and dams. We're not going to really talk about this too much tonight, but I did want to point it out because it's been a really great opportunity for NepRWA in our restoration and advocacy work to have really done a comprehensive comprehensive survey of these barriers to fish populations and fish passage. Since this was done in 2021, we've taken out that one dam in Norwood. We've been working with towns on a couple of different culverts that would serve both fish passage and climate benefits. And we've been in discussions about a couple of these dams. So having been able to pull together a priority list of what we should focus on first has been a real game changer for the organization. And kind of the second thing we found from this is looking at, now that we know where trout are, if we kind of ask what features of those streams, what features do those streams have, the ones that have brook trout? And this one we kind of looked at 2 different things. So over here on the left, we have basically habitat diversity. It's a bit of a confusing unit here, which is number of hydraulic habitat units. Basically, it just means how much habitat is there. Is this an area that has a mix of pools, runs, riffles, or is it something that's pretty channelized, one note, one habitat? And what we kind of find is that where trout are present, there tend to be more habitat types. It's not a huge difference, but it is a difference. So it is, kind of get into that first thing I talked about land use and habitat loss driving some of these changes. It's just something to keep in mind. But I think the big takeaway and what's really fed into the second phase of our work has been this looking at temperature. So if we look at spring and summer temperatures where there are and are not brook trout, starting even in the spring, you can start to see that areas that are cold water stream but don't have trout tend to be a little bit warmer. They're starting to cross that 20°C threshold. And in the summer, they're much warmer and significantly warmer. But what you might also notice here is that even the streams that are present are above that DEP threshold for 7-day temperature maximum. And what that means is we have trout, we have cold water fish, but they're living right on the edge. There's not a whole lot that would push them over into areas where they're not able to exist anymore. So it's really important that we take advantage of the fact that we have them now and we know that they're living on the edge in order to work with our towns, work with the state to preserve them before they're lost. Because once they're lost, it'll be almost impossible to get them back. So that's all kind of what we had done in this prior 2019 through 2021 study. And kicking off Embrace the Stream 2.0, and I feel like I meant to say this earlier, the Embrace the Stream name is, and this project was funded through a grant from TU National. It's a program that helps conduct research and conduct improvements and volunteer and resident connection to streams. It's been a great help, as I said, to prioritize some of NepRWA's projects over the last couple of years, and it's been a great partnership with both GBTU and the national office to get this work done. So this second phase project, what I'm going to talk about the rest of tonight, is our Embrace the Stream 2.0, primarily looking at these road crossings on our known trout streams. So we've been collecting data on road crossings and stormwater runoff. What we're really doing is we're looking at upstream and downstream of road crossing. So here we're downstream of Sumner Street in Norwood, flowing into that restored area of Trap Hole Brook. We're looking at temperature and dissolved oxygen below the road crossing, temperature both above and below. We're going to talk a little bit about thermal imaging of groundwater and runoff, and looking at macroinvertebrate assessments. So the things that live in the stream that are not fish, the things that don't have vertebrae. Kind of when we wrap up the data, we're going to talk about how we've used this project to engage with students and develop a middle school program on brook trout. And then finally, what this is all for. I mean, as a scientist, I love collecting data. It's great, but it really has to mean something. And so the overall goal of this project is to inform advocacy with local government. We want to take this information, we want to know what it means, we want to use it to talk to town conservation commissions and DPWs about protecting cold water streams, especially where there are major road crossings where something could be done. A lot of times when we talk about water quality issues, there's a big diffuse issue with non-point source pollution, and it's a typical thing to wrap your head around. Road crossings that have storm drains have a very specific pipe that you can work on improving the situation with. So that's kind of what we've targeted this project for. And the end goal is to kind of really engage with the decision makers at the local level to make this productive. And just giving a sense of the project timeline. So again, this is a 2-year study. So we did our dissolved oxygen and temperature monitoring both years in May through October using continuous data loggers. We did thermal imaging in the winter of 2025, and we'll talk a little bit more about why we chose winter of 2025. We've collected macroinvertebrates both summers. So it's once a year, but in the summer. And we'll talk again about what that means and why we chose that. And our program, for our school program, we spent the last 2 years developing it. We've got a great educational team at NepRWA, and it's now gone through 2 educational coordinators and our outreach coordinator to really fine tune it and make it great. And we've sent it off to a few teachers to pilot it. We're hoping they'll pilot it. I think there was at least 1 pilot through the fall, and a few more teachers have told us that it's in the pipeline for the spring of this year. And as I said, the end goal of this is municipal advocacy. Obviously, we wanted all the data together before we really kind of converged on a message to the individual towns. So now that this study is complete, we've had to present these findings in our communications with the conservation commissions, DPWs, other decision-making planning departments across the watershed. So as I said, we're focusing in on the areas where we know we have brook trout based on that prior study. And really what we're going to focus in on is 3 of our streams that have the most brook trout from that eDNA study and also have rather significant road crossings. So it's kind of 2 things we're kind of fitting together, which explains why we're going to narrow down from 5 to 3. And what we're going to look at is Pine Tree Brook in Milton, Trapple Brook in Norwood, and Germany Brook in both Westwood and Norwood. So these are the areas that had the most trout, but also had some major road crossings, which Beaver Brook, even though it had a pretty big trout population in Sharon, the areas where the trout are present, there's not a lot of road crossing there. So it's not a really great area to conduct the study. All right, so we're going to talk a little bit about the data collected and the results. As Matt mentioned, if you've got questions, pop in the chat, or if you raise your hand, if you really need to, ask a clarifying question, feel free to do that. But we're going to kind of step through each of these things bit by bit, and hopefully hopefully it'll all come together as we talk about it. So as I said, we've been doing this continuous data logging for the past 2 years, and the reason we're looking at them both is obviously that both the trout depend on cold water and high oxygen, but they're also inherently linked. So cold water holds more oxygen. The warm the water is, the less oxygen it will hold just by the physics of how gases dissolve into liquids. And high water temperatures will cause stress to trout over the long term. So these 2 go together, they're hand in hand. But as we'll see, as we talk about,
when I was cursing myself to have chosen this job.
does someone have a question?
I think it was just background noise,
Okay.
Sean.
No worries. So as I said, those 2 are tied together, but we'll see as we go on. There might be a little bit of a lose-lose decision making some of our trout will have to make, and we'll talk about that in a bit. But we've been collecting these with data loggers, and that allows us to sample over the entire summer season. It allows us to sample overnight, collect data, everything that's happening, every rain event that happens without having to be there in person, standing there with a hand probe. So what we're going to look at today is what DEP considers cold water temperature, which is the 7-day rolling average temperature. We're going to look at the influence of stormwater and the minimum dissolved oxygen we see throughout the summer. So we'll kick it off with the rolling high temperature. So it's a little bit of a confusing metric here, but DEP regulations are that cold water streams should not exceed 20 degrees Celsius in a 7-day rolling average of the maximum daily temperature. And it's a little bit confusing, but what that means is basically condensing it down to the maximum temperature experienced in a day, averaged over 7 days, should not exceed 20 degrees Celsius. And that's what we've got here on the graph on the right-hand side. This is the rolling average temperature on those daily maximums. And this is the Route 1 crossing on Trapple Brook. We picked it both because Trapple Brook is one of our best trout streams, but also Route 1 is a fairly major road crossing. And as you can see, there are 35 days in total where the rolling average is above 20 degrees C, which means that that's a whole month, a little over a month for the water to be too warm to be considered habitable for brook trout. And obviously that doesn't mean that the trout are all going to die. It means that they have to seek refuge in those deeper, colder pools, in those groundwater enriched seeps and areas that kind of act as refuge for them. But it does mean that while they're hiding out, because it's too hot to swim around, they're unable to move between populations. They're unable to fully utilize their habitat in their feeding, in their in their day-to-day activities as they prepare for the breeding season in the fall. So it does put them in a little bit of a disadvantage to be restricted to those thermal refuge areas. Now we're going to talk quickly about upstream versus downstream temperatures. So as I said, we've been collecting these long-term continuous data both above and below the road crossing. So this is just looking at temperature change above the stream and below the stream at Route 1. And I wanted to focus in on one particular time window here, which is that across the board, we see the temperature change from the upstream to downstream is relatively minor. If you average across the entire summer, depending on the site, it's about 0.3 to 0.5 degrees Celsius. It's not a huge change. The exception is following major rain events. Even then, it's a little bit, it jumps up to a degree, maybe two, a degree, maybe a degree and a half. And it's actually a relatively transitory thing. One thing we'll hit on again and again in this presentation is even though we're looking at upstream versus downstream, our upstream area isn't pristine. So at some point in a rainstorm event, you get a first flush off of a roadway, which kind of warms the stream temperature. But eventually the upstream water warms as well because there's a road crossing further upstream somewhere down the line. But we don't want to focus in on this July window from this past year. So if anyone remembers July, there was a really rainy event. I think it was 3.5 inches in a single day. And you can kind of see this temperature change. So this is, it's 2 degrees warmer at the downstream site than the upstream site because it's all that warm asphalt being cooled down by rain and all that now warmed rain running into Trout Brook. And so the temperature jumps up dramatically, 2 degrees warmer than it was upstream. And you can imagine that if you're a trout swimming through this and you're pretty sensitive to water temperature changes, 2 degrees is going to mean a lot. It's going to be really quick and really negative experience for you. So there's a couple other things, and broadly speaking, the temperature changes from upstream to downstream are not, they're not massive and they're not, consistent except for the periods of rain. But there are these brief periods where it is really important to point out just how impactful on a short time scale these stormwater runoff events can be. And just kind of give a quick summary of those temperature conclusions. The road crossing impact is not showing a particularly strong signal in temperature, more than it is saying that across these sites, upstream or downstream, we have a general trend of stream temperature elevation. And this is the data from last year by Chris Amon, who's a grad student working with us from Northeastern. These are percentage of days in the summer that were greater than 20 degrees Celsius. And you can see there's not a whole lot of difference between the upstream and downstream. In fact, some of these sites have warmer upstream locations than downstream ones. And just for sake of people following along in the site codes, this is Pine Tree Brook at Blue Hills Parkway, Pine Tree Brook at Canton Avenue in Milton, Trout Brook at Route 1, Trout Brook at Sumner Street at the Peswick Park, Jeremy Brook at Sycamore Drive, and Jeremy Brook at Westover Parkway. So as I said, this is a general trend of warmer streams, which we kind of already knew about. It does tend to drown out the noise of, it tends to drown out the impact that the road crossing has. But as we kind of just saw with that, that peak rainfall in July, it is important, even if you average it over the entire summer, it is difficult to see that signal. Putting that out there. So I talk as the last thing of our continuous data is minimum daily dissolved oxygen. So this is looking at how low does oxygen drop in a given day across our study. And again, we're focusing on the Route 1 crossing of Trout Brook just for the sake of time, but we've been looking at this for the rest of the sites as well. And what we're seeing here is not unique. We're seeing this kind of at most of our sites is Actually, for the most part, temperature oxygen does stay in, the quote unquote good threshold for cold water streams, which is more than 6 milligrams per liter in concentration. We like to see more than 5 for warm water streams and more than 6 for cold water streams. And for the most part, we are seeing that. And even in areas, even in time points when it does dip down, for the most part, we're not getting really hypoxic conditions. We're getting, what would be considered normal for warm water streams instead of cold water streams. However, as I said before, there's a little bit of a disconnect with the water temperature and dissolved oxygen. Cold water holds more oxygen, but groundwater does not contain significant oxygen. So we're going to talk a little bit about searching for groundwater, but if you think that you're a fish swimming through the water in a warm summer and you need to find thermal refuge, you're going to find a cold water seep, which is primarily fed by groundwater, but you're also being pushed into an area where the primary source of water is low oxygen water from the ground. And so you're kind of at a loss here. Either you spend more time in warm water where there might be more oxygen, or you spend your time in cold water, which counterintuitively has less oxygen because it's coming from the groundwater. And so that's really important for us to follow up with that point, look into the groundwater sources and find ways to bolster them in addition to kind of offsetting the influence of the roadway crossing itself. All right. So as I said, we kind of want to look now that we've kind of left our continuous data behind, we're going to look a little bit about at this groundwater question. And so the first thing we can ask ourselves is how can we look at groundwater, right? It looks the same as regular water, but it's an important source of cold water in summer for the trout. And as I said before, it's providing thermal refuge in overheated water. And the way that happens is that groundwater is just very consistently the same temperature year round. It's typically between 7 and 13 degrees C, which is 45 to 55 degrees Fahrenheit. So that means now in a blizzard right now, if you were able to dig down into the ground, it's still, about 50 degrees Fahrenheit. And in the summer, it'll be about 50 degrees Fahrenheit. It provides a nice consistent, provides a nice consistent baseline and cold source or refuge from heat. And when we do thermal imaging, which you can see here on the right-hand side, using infrared camera technology, we can distinguish warm versus cold features, and we can distinguish cold spots in warm weather conditions. So we're looking at the stream here. You can see that this is taken in the summer. The stream is around about 22 degrees Celsius, and the shaded bank, is about 13 degrees Celsius or thereabout. So that bank and the vegetation is providing a cooling feature. But if we kind of enhance that picture a little bit and zoom in, this little band, I don't know if you can see my mouse, this little band right along the bank where it's slightly cooler than the rest of the water is a groundwater seep. So groundwater is moving out of that porous bank. That cold groundwater is kind of helping temper that warmer stream. And if this were a cold water stream, which I'm not sure it is, it would be providing a little bit of benefit to the fish that live there. So we're going to go ahead and look at groundwater with this thermal imaging technology, but we have faced a bit of difficulty with this. So cold seeps can be confused with shading. Up against that bank, is that really a cold water seep, or is it just too close to the bank to tell? Unless the discharge is really high, it can be a little bit confusing. The other problem is that cold water is denser than warm water. So it's going to sink to the bottom and it's not going to mix, which means that if you're going out in the summer and you're looking, you're going to see a stream surface that's uniformly warm, but you don't really know what's happening underneath the surface. It could be nice and cold, just a little bit, just a few inches deeper, or it could be warm all the way through. With camera-based technology, with light-based technology, it would be difficult for you to tease those two apart. So the solutions to those are some studies have run fiber optic cables to do point sensing for temperature. That's pretty expensive and it requires a lot of setup. It's not very mobile. So instead, we considered an alternative in conversations with USGS and Dr. Briggs. He recommended doing winter surveying. So the thing is, we normally, when we talk about groundwater for fish, we think about that groundwater as being the nice ice cold water. But really what it is consistently temperatured water, which means that right now in the winter, it is nice and warm, which is less relevant to trout, but it makes it much easier to detect. So in the winter months, the warm water is going to rise to the surface because warm water rises, and it's going to be more visible for us to be detecting those cold water seeps or groundwater seeps, which will be cold water in the summer. Also, if we do this in the winter, we reduce canopy cover and bank vegetation that can get in the way of access, but also, those shade effects, that ambiguity, is this a shadow or is this colder water? And here you can see our intrepid volunteers braving the elements this past winter. I think it was something like 10 degrees out this day. It was really cold, but they were great spirits and going out to survey the water. And you can see them both in real color and in thermal image down below. So we're going to look a little bit at some of the thermal imaging and see if we can identify some groundwater sources in our streams. But there are some issues that remain. In particular, sun-warmed rocks and banks in the sun can make those seeps harder to detect. Very similar if reversed from the summer situation. Areas where the sun can warm something up is going to look like it's warm. And is that groundwater or is that solar energy? It's a little hard to tell. And if we look at some of our thermal imaging, and apologies that these are not the clearest of images, but again, you can see that the warmer colors are warmer water, or warmer temperature, and the cooler the temperature, the colder the water. So here we're looking to see if we can find warm spots of water in a cold background. And what we kind of see is these are two areas of bank, one along Pine Tree Brook and one along Trap Hole Brook. And I apologize, I was hoping this would come out clear. I couldn't get the image to come out much better. But if you can see my mouse, right here, there's a thin layer of blue running through here. This is the kind of background stream temperature. And right up against the bank, and actually right up against this area over here, it's slightly warmer, which suggests that it's a groundwater seep, both from the bank and from the porous subsurface of the stream itself. It's not huge. Normally when you see pictures of cold groundwater plumes, you'll see a pretty distinct signal, and it will show some mixing currents. It's pretty small, relatively speaking. And you see the same thing here in Trap Hole Brook. There's this patch of cold water surrounded on both sides by slightly warmer water. And if I could show this to you both in real color and side by side, you can see that there's slightly shallower water, but also a muddy bottom where there's a likely groundwater seep coming through here. And when we did the survey across all of our 6 sites, we found the groundwater, some of these small groundwater discharges in the banks, most of them along the banks. There were a few in the mid channels, again, those kind of more mucky bottomed areas where there's a little bit more, not mucky bottomed, sorry, porous bottomed is what I meant. Porous bottomed areas where there's a little bit more interchange and release of groundwater, but they're relatively isolated, they're relatively small. There aren't any significant plumes in the areas directly adjacent to these roadway crossings. So this does give us an important piece of follow-up. We are hoping to do and would need to do a longitudinal survey of the stream to identify other locations where groundwater is entering the area, and also revisit these sites, go back year to year and see, are these areas where groundwater seeps happening consistent? Are these something we can plan around, that they're always there? And maybe it would make sense to revitalize the bank in this area or improve canopy cover in this area to kind of help out the trout? Or does it change year to year? What's the stability of this? Can we plan around it, and can we build it into a restoration or revitalization project? So that's certainly something to follow up on. And now that we have the thermal imaging technology, it's something we can do alongside our other work without it being, something that we need to fundraise for a great project on. We can do this work as we go and kind of enhance our understanding of these systems. And the second thing we wanted to do with thermal imaging, unfortunately, we weren't able to quite accomplish the way we wanted in this study, is really looking at what we call the first flush. So this is what we call that first initial runoff of rainwater, the ones that carry the most pollutants, that carry the highest concentration of sediment, excess nutrients, excess dirt and car exhaust and oil, and thermal energy. So this is an image from the Desert Research Institute in Nevada, but this is a sidewalk instead of a stream. But you can see here areas where the sun is uninterrupted onto an impervious surface like a sidewalk. The temperature gets really, really hot, up to 131 degrees Fahrenheit, and that first few minutes of rain is going to carry almost all of that thermal energy into the stream. And so what we hope to do is visit the stream during a rain event, right at the start of the rain event, so we can see the first few minutes of water exiting a storm drain and see how much hotter it was relative to the flowing stream. Unfortunately, this past summer, actually the last two summers we've been doing this have been spotty for rain overall. And the rainfall we've been getting recently has been high intensity storms that make it a little bit difficult to, ethically ask someone to go stand out in a stream that you know to be a little bit flashy. So unfortunately, we're still looking to do this maybe in the future, but we're able to get the same information from our data loggers. We do have storm drain data loggers that were part of the study. But it would be nice if in the future we can get a great visual shot of how much thermal energy is entering the system from these first flush events. And the last little bit of science piece we're going to talk about today is the macroinvertebrates. So for those who don't know, macroinvertebrates is the collective name for all the non-vertebrates living in a stream. So your insects, your snails and mollusks, your worms. And the reason we care about them, the reason we want to know and use them to analyze this data is that they're an incredibly diverse group. There's, I don't even know how many different species in the hundreds of thousands probably, but even at the broader taxonomic group that's really easy for people to identify, there's somewhere around 30 to 50 different categories of macroinvertebrates, and they have different ranges of sensitivity. So there are those that are very tolerant to pollution, that can live in anywhere, like mosquitoes and midges, and those that need cold, fast-moving water, just like brook trout, like your caddisflies, your mayflies, and stoneflies. There's also a range in how adapted they are to faster flows, those that are more suited to slow-moving water, more like pond-like water, or fast-flowing water. And there are also some species that are adapted to flashy systems, the systems that will, relatively quickly build up fast flow and then kind of die down. So because there's such a diversity that we can expect out of these populations, what is living in an area tells us what the system has been experiencing over the past couple of years. They're easier to sample than fish. There's less risk of a negative ecological impact. You can't, even if you were to take a bunch of samples, there's hundreds of more bugs left in the stream, which we try to respond ethically to our surveying, but is the risk of accidental fish death is going to affect the system more than the loss of any of these macroinvertebrates for sampling purposes. There are some drawbacks. macroinvertebrate samples tend to be time consuming to process. So if any of you were part of our volunteers who contributed to it, you know how long it takes. They can also be more variable year to year based on weather and sampling, and fish populations tend to be a bit more stable. So it's a little bit of a trade-off. We can learn a lot, but it does tend to be a little bit time consuming and a little bit variable. That makes it hard to draw conclusions without a huge sample size. And as I said, reason we're looking at these is because they have such a range of tolerances. So what we're looking for in particular is the pollution intolerant insects, the ones that can't withstand a lot of urban pollution, and that if they're there, it means that the system doesn't get a lot of this pollution. We call these the EPT, which are Ephemeroptera, Plecoptera, and Trichoptera, or mayflies, stoneflies, and caddisflies. You can see here in our wonderful pictures from Chris. We're also looking at total richness, which is just the number of taxa, how many different things we find, and what's called the Shannon-Wiener index, which is just how distributed are the taxa we find. Are there a lot of very rare species and only one common species? Is there a nice even mix of everything we find? Those are the things we focus on for this particular phase of the study, but in the future, with the data we have, we could also look into things like flow tolerance or functional feeding groups that tell us a little bit more about how these streams are responding. Are they getting a lot of leaf material that's kind of acting as the base of the food web, or is there a lot of algae and filter feeding based food web? Is there like a lot of grazing on aquatic macrophytes in this area, or is it a system that requires a lot of input from upstream? And prior work, as I said, for those of you who attended Chris's presentation a little over a year ago, Chris had done really excellent work looking at the macroinvertebrate data from that first phase, the first year of the study. And his general findings were that the upstream sites had slightly higher richness, although not significant, and Shannon-Wiener indices that were slightly higher than the downstream locations. So again, just slightly more species, a little bit more even on the upstream side relative to the downstream side, but it was not a significant result. The percent EPT, so this pollution intolerant metric, is a little bit more variable. There were some sites like Pine Tree Brook where the upstream side had more EPT than the downstream side, which is kind of what we would have expected. But other sites like Trout Brook and Germany Brook, the sites alternated. There was either more on the downstream side or equivalent between the two. So it's a little bit of a mixed message or mixed result in what's happening with the pollution tolerance relative to what's coming off of the roadway crossing. And then Chris had also done some kind of fabulous work looking at multivariate analysis. So what we've kind of talked about so far are these like single numbers. There's 10 species. There's a Shannon-Wiener index of 1.5. And they're very helpful for knowing what's happening in a stream. But if you want to know the entire story of what's happening, you can do multivariate analysis, which is basically looking at all the different species that you have, putting them all together and saying, if I have this assemblage of species at this site and this assemblage of species at another site, how similar are they? Are they pretty close together? Are they completely far apart? If I add a third in there, is it closer to site A or site B? And unfortunately, Chris put in a lot of work, and we really appreciate it, but his multivariate analysis showed that more of the differences were separating out by the stream itself or the site, rather than whether it's before or after the road crossing. So these are Chris's graphs from last year. I just want to put them out there so kind of refresh ourselves. Here we have that upstream and downstream difference. So you can see that these this black and pink polygon kind of represent the range of sites based on their macroinvertebrate populations. And the more overlap they have, the more they have in common. So you can see there's not a lot separating out the downstream side from the upstream side. However, as we move to the right, now if we look at it by stream, so Pine Tree Brook over here, Trapple Brook over here, and German Brook over here, we're seeing a little bit more divergence. There's a little bit more, let's see, there's a little bit more amphipod-driven communities over in Pine Tree Brook. There's a little bit more mayfly and trichoptera-driven species in Trapple Brook. And then if we look at it by site, it's kind of breaking down, you can draw your little polygons from it, but these are the same results. And we can see that when we look at road crossing, we're seeing that these these sites, upstream and downstream, are much closer together than they are to any other site that we looked at in this study, which does tell us that, it's not that stream crossing isn't having any impact on the macroinvertebrate community, but it is being drowned out by the larger differences between these streams across the watershed. And I know I don't want to spend too much time. I want to leave time for questions. So just looking at the year-to-year differences. So this is, again, focusing on Route 1 crossing because it's that major road crossing. We can kind of see here is identical richness, not too different Shannon numbers, although they're a little bit different, but the percent EPT can vary quite a bit. So at the upstream crossing, it's pretty consistent, 40 to roughly 25 is a small change, but at the downstream side, it went from 10 to 42. And really what this means is that when we do the sampling and we're restricting it down to what volunteers can process at a reasonable time frame, this is 25% of the total sample, it's going to be skewed a little bit, just hit and miss by what insects you find. So this is even all these sites together, they're under 30 total invertebrates. So, if you think about a sample size of 30, if you have one or not one caddisfly, it's going to change these numbers much more dramatically than if you have 1,000 invertebrates, and missing one or counting one in your sample is not going to shift the results by quite so much. So when we do this macroinvertebrate sampling, where we take a sample and we break it down and we depend on volunteers to put in a considerable amount of time and effort, unfortunately, it's going to be a little bit hit and miss when not through any fault of the sampler, just by breaking it down and taking subsamples to make it realistically feasible. So these year-to-year differences are going to be driven by just presence, absence, time of year changes, some things we can't control, and really kind of what we see from this is that the macroinvertebrates of these sites aren't showing a lot of conclusive evidence of road impact. Again, kind of what we saw with temperature, this is an urban watershed issue. The upstream site isn't pristine. It's just downstream of somewhere else. And so we're not seeing a huge impact that can be, really pinned on these road crossings that's going to make a strong case. There is an important case to be made, but we want to be realistic and we want to be truthful about the data and kind of focus in on what it's telling us. And so the takeaways from our macroinvertebrate study is, again, these year-to-year differences and the differences between the different streams are really outweighing those above and below road crossing differences. And that, as I said, some of the issues with doing the sampling, there's high variability due to some uncontrollable factors. So in 2024, there was a drought. 2025 had a drought, although later in the year. How fast did the winter warm up into spring? How many of those insects emerged deflated adults and left eggs behind and were unable to be in our sample because they were off laying eggs elsewhere? All those things are really uncontrollable if you try to, as much as you try to control for things, they're high variability that's it's going to be really difficult for you to factor in. But there are also some controllable differences. There's sampling technique and volunteer differences. And again, I'm not saying that any volunteer did it wrong, but it's just differences when one person's doing it versus two different people are doing the same thing, right? It's just a little bit of difficulty in controlling for, just technique and and approach. So we have been thinking about this and some potential solutions that address this sampling difficulty. We've been talking with the Charles River Watershed Association, which has been doing a lot of work in macroinvertebrate assessment and how to get that incorporated into state assessments. And they've been having a lot of success with stream site assessment versus permanent collection. Means it goes faster because you're sitting on the stream side, you're not preserving the bugs and picking them under a microscope later. You're using the fact that they're alive, you can quickly count them. It takes a little bit less time, although more time in the field and in the heat, less time overall. And what they've also found is that having dedicated samplers for particular sites provides a consistency because people are doing things exactly the same way. So we've been working with other watershed groups on how to fine-tune this, macroinvertebrate or aquatic life-based assessment stuff. And hopefully this has been a really good learning experience, and hopefully we can kind of contribute more to using these macroinvertebrates to tell us about these streams in ways we can kind of reduce that variability and also reduce the time burden that we're asking for volunteers, because it is a lot and we really appreciate the effort they put in. All right, I know I've been talking for a long time. I promise I'm trying to get through so we can get to your questions. Just real quickly on the scientific takeaways, thermal stress is the major concern we have in our watershed. It's the thing that we know that our streams are living right on the edge, and every summer with a intense drought, and every day over 90 degrees gets us closer to losing this vital resource we have. We kind of looking at those temperature and oxygen metrics. We may have identified a little bit of a paradox where those high summer temperatures are forcing trout to seek out cold water refuge that's fed by groundwater, but those groundwater springs may have limited oxygen. So it may be something we want to do about that in terms of promoting groundwater and shading around those areas by plantings or bank stabilization with the live staking that Mike mentioned at the start of the meeting. Ways we can kind of just reinforce and help out the trout as much as possible. Using the thermal imaging we've developed, we can also identify cold water springs, cold water in the summer, and increase that canopy shade to help trout both survive the summer and also thrive in the summer. And again, for the macroinvertebrates, we found that there's not a lot of substantial difference due solely to road crossings. There's a broad pattern of urbanization across all of our sites. And so maybe if we were to continue the study for longer periods of time, we would be able to tune out that noise a little bit through increased sample sizes, but really it's not as big an impact as we're seeing with those specific rain events for that upstream and downstream impact. And just generally overall, what this data is really telling us is not really a surprising thing, is that for a watershed like the Neponset, broad-scale habitat improvements, tree plantings, dam removals, reconnecting our streams, stabilizing banks, and revitalizing stream banks may provide the most benefit to trout. Obviously, these projects are, in large part, especially dam removals, very expensive. They take a lot of time and permitting. So it's not to say that stormwater control measures can't be helpful. They certainly can, but we need to be doing both, and we need to be kind of pushing on both these levers at the same time. In addition, as we think about ways we can talk to the municipalities about these roadway crossings and how to encourage them to put in stormwater control measures like a rain garden, like a detention basin, like a infiltration trench, is that the one thing the study didn't look at is pollution like phosphorus or oil runoff or a chemical of particular concern for trout, which is, I'm going to get it wrong, 6 ppd something. Quinone, I should have written it down before the presentation today, but it's a chemical found in degraded tires that affects salmonid species like trout in their life cycle. And if we can find a little bit more information about that, if we can find proxies for it, because testing for it specifically is a little expensive, all these things are going to push in the same direction, which is that although it may not be the biggest threat our trout face, these roadway crossings and the thermal impact from them, the pollution impact from them, the just high flow impact from them is all a negative that could be ameliorated with some kind of stormwater control measure like a rain garden or like an infiltration trench. All right. Before we get to questions, I do want to talk really quickly about the school program because I do think it's great. Part of what we proposed to do in this 2-year study was collect all this data, which has been fabulous, but also develop a school program. So we've been hard at work making a self-contained lesson plan for middle school students. It focuses on trout ecology and human influence, and you saw the video from Paul earlier as a component of that classwork. And it really relies on some fabulous people at NepRWA who are not me, who do education work. And they already operate a what we call a traveling program for elementary schools. So almost every elementary school in our watershed gets a 5th grade class, gets their 5th grade students to experience a stormwater and water conservation lesson plan. And here you can see some students playing with our Enviroscape, or what other people call watershed in a box, where they can see how pollution moves across the landscape when you things like dog waste and fertilizer, and see how it moves from the streets, from your yard into local waterways. So we're kind of building on that learning expertise to develop a self-contained program that teachers can adapt for themselves. The plan is to hand them over a PowerPoint, a set of handouts, a teacher's guide for a two class or 2-hour workshop on trout ecology. And just to give you a quick peek of what that looks like, our wonderful education coordinator, Emily, put this together and framed it around the classic whodunit mystery. So we've noticed that brook trout are disappearing all across Massachusetts. Why are they disappearing? Let's solve that mystery. And it allows them to work through some specific examples and worksheets. As you saw Paul mention, kind of the mantra for brook trout is cold, clear, clean, and connected waterways. This allows the students to kind of play around with different real life scenarios and which one that may be impacting the trout with. So if it's a climate change driven feature like temperature in Massachusetts has risen by 3.5 degrees since 1900, that is affecting cold water. It's making the water more warm. If it's developers buy a wooded undeveloped land with a stream, they cut down the trees and they build a house, that's going to affect whether it's clean or clear, because there's going to be a lot more sediment runoff. They're probably going to increase the impervious surface in the area, or maybe they're going to build a little bit of a garden and increase fertilizer runoff into the stream. Just a different ways that we can get students thinking about the way both town impacts and personal impacts can affect the health of the species around them. And then it ends up with this kind of comprehensive project of looking at a proposed school development, which is going to impact a make-believe stream called Splashing Brook. It's going to involve the development of a new pond, stormwater controls, more impervious surfaces. It kind of walks them through and works with students to figure out what issues that's going to create, what alternatives there might be, and ways they might communicate that to the local decision makers, like the school board or the select board of their town. So it's both an education about the science, but also a advocacy in what can you do in your day-to-day life and in your advocacy life as a good steward of the environment. I will say the implementation of this program has been a little bit of a challenge. We've been having difficulty connecting with enough schools and teachers to put it into classrooms, but we currently have 4 teachers that have told us they're considering using it in spring 2026, and we're committed to revising the PowerPoint based on their feedback. And once we've gotten kind of a thumbs up around the board, we tend to put this on our website to make available for all to use as desired. as we try to make this as user-friendly for teachers as possible. So it's fully self-contained. It requires nothing more than the Google Drive we send you, but you're also welcome to adapt it however you see fit to make your classroom benefit the most from it. And this is just a little call out that we have on our website for teachers to reach out to us. We've been reaching out as well through other connections to try and get more more eyes on this work and more students to experience this lesson plan, so we can make it as best as possible and convey more of the wonders of trout and brook trout ecology to the students in our watershed. And with that, I just want to say thank you. Thank you for listening. But more importantly, thank you for the more than 300 hours put into this project by volunteers. More than 44 people worked on this project, putting in a lot of time and work, weekends and nights, sitting at a kitchen table with macroinvertebrates, or sitting in the sweltering heat and downloading a data logger. This work would not be possible without the volunteers from GBTU and NepRWA, and we really appreciate it. We also relied pretty heavily on a few academic help. So as I mentioned, Chris Amon was a master's student from Northeastern who did a lot of this analysis from the first year of data and really kind of helped set up the framework and help helped manage the volunteers and keep everything on track. In this past year, sorry, I guess almost got her name wrong. Lauren Martinek from Framingham State analyzed some of our data as well for her senior capstone. And we really appreciate the help they both provided. So with that, I'm happy to take any questions.
Sean, we got a couple of questions in the chat, which I can read, but before I do that, I don't know if anybody has any questions they want to ask live. All right, I'll go to the chat then. First question is woody debris considered good or bad for stream health?
That's a good question. It is, I think generally speaking, woody debris is considered good for stream health. It's important to create nooks and crannies for young fish to hide in, but it is a balancing thing. You don't want woody debris to create a barrier to passage, an artificial dam, unless it was designed by a beaver, which brook trout and beavers coexisted for hundreds of years, thousands of years. So they do have ways of getting around beaver dams, but generally speaking, woody debris is considered a positive for brook trout.
Next question was, is there any legislative activity, either here in Massachusetts or federally, that would help get rid of old defunct dams?
That's a great question. For old defunct dams, there's not a specific legislative action happening, but there is within the Department of Fish and Game, there is a division of ecological restoration, DER, that does dam removals. We advocate along with our partner watershed associations and Mass Rivers Alliance, which is a statewide watershed advocacy group. We advocate for ever increasing DER's budget because there's a lot of dams to take out and there's a lot of work to be done. But they are wonderful at being able to both manage projects and locate other funding for it. So they're able to leverage state funds, but also find federal funds, find private or foundation money to kind of restore these areas. And I will say there has been federal funding before it. It obviously does, vary with administration priorities, but there have certainly been federal funding opportunities, and we hope to have more in the future as well.
Next question was, in the photos of stream crossings, or the stream crossings look good and well designed, but how many other stream crossings are less well designed, such as with perch culverts, etc., that interfere with fish passage?
Yeah, that's a really good question. And actually, that's one of the things that we found from our first study back in 2019, the Embrace Stream 1.0, is there are a lot of culverts that are undersized or perched and unable for passage, unable to have adequate passage, or they're too small. In particular, one that we've been working pretty relentlessly on is a culvert in Sharon under High Plain Street, which connects the headwaters of Trout Brook with the rest of Trout Brook. It's in rough shape. It's too small and it's eroding around the side of it. Unfortunately, it's stuck in a situation in which replacing it costs too much money for the town, and not enough to attract, or there's not enough specific benefit to attract, some of the private money or federal money to get us over the hurdle on it. But there are a lot of perched culverts or degraded culverts that need right sizing, need replacement. We focused on these ones because they were large enough to contribute meaningfully to the stormwater, and relatively easy to access for consistent monitoring. But we could definitely do a study in other places too.
All right, next question for you was, are you hiring any interns this summer?
Yes, we are working on putting out an intern call very soon. Should hopefully be up by this next weekend. But we are hoping to bring some interns on. I think we're hoping to bring on one summer intern in the water quality side of things, and then I think one for our clean waste program as well, which is more about access and trail discussion.
All right, and we've got some other questions in the chat that are maybe not specifically to you, Sean, or maybe they are, but one is, who can we reach out to about volunteer opportunities? And it looks like Rui provided a link to our GBTU website in response to that. I don't know if there are any sort of specific volunteer opportunities that Emily was looking to get information about, but I know, like, generally speaking, any work that GBTU is doing with NepRWA, like, we are promoting that or getting the word out in our newsletters, on our website, our event center. So there are special sort of opportunities throughout the year. I know NepRWA has a number of other events going on throughout the year that we also participate and volunteer at. But I don't know if Mike or Sean, if there's anything specific you want to say about the question on who they can reach out to about volunteer opportunities.
Hey, Matt, I just wanted to drop in and mention that we typically have 2 creek cleanups every year, one in the fall, one in the spring, in addition to the vegetative planting efforts. Those are the volunteer efforts that I'm aware of.
Yeah, that's actually a really good point. And I'm going to put it right now in the chat. We do have our spring cleanup coming up, which is, I think, April 25th. So you can go ahead and register on there to be part of our cleanup. There will be a GBTU site. I think site location to be determined, but GBTU has been a great partner in cleaning up our watershed. In terms of volunteers as well, if you're interested in volunteering with NepRWA, if you go to our website, there's an option for volunteering, and I'll connect you with our volunteer coordinator, Suzanne.
Yeah, thanks,
And then
Sean.
I actually had a question I wanted to ask. I know we're running a little bit over on time, but given that the project here that you've been summarizing so nicely is a really great presentation, and all the work that NepRWA has done to support this project is really, really appreciated. My question is, sort of as we come to the end of this project, do you think that we have answered our questions or our hypotheses that we initially set out to answer at the beginning of this project? Or do you think that there's still more to be explored in the future, potential future projects?
That's a great question. I will say, coming from an academic background, I don't think you can ever fully answer a question without raising more questions. It's always good to collect more data, but I do think we have answered a lot of the questions we set out to answer. Maybe not as resoundingly as we hoped we would, but I'm hopeful that we can use this information to talk with the towns and convince them of the need for some improvements on, especially this major road crossing in Trout Brook. It tends to be, it's a pretty big impact that you can see in that discharge, but also I think there's opportunities to do both. There's opportunities to do more scientific exploration and more advocacy or removal or restoration projects. And I know GBT has been a partner in both.
Great, thank you, Sean.
Thank you all.
Appreciate it. If anybody has any more questions, feel free to jump in. I would say also, if folks are interested in volunteer opportunities, please reach out to me. You can email me. Just reply to any newsletter you get from me, and let me know if you're interested in volunteering in any way. We'll get you hooked up with the folks who need the help. So
Great.
So Mike, I actually did have one more question for
yeah,
Sean.
go ahead.
We have them, and I know we're, it's getting a little bit late here, but yeah, I've given this some thought. So my question is, what, don't want this to be taken as a critical comment, but in your estimation, Sean, what is the value of the presence of brook trout in the Neponset system beyond, it's cool that they're here and it's very interesting, given that they aren't really significant fisheries for, recreational purposes. And I think, like, to me personally, it is cool that they're there, but I also think that they're populations that, for all the reasons that you highlighted, are probably relatively fragile or at risk of, being susceptible to changes in the system. So I guess the question is sort of back to, like, does the presence of brook trout in the Neponset system, does that inform thinking at NepRWA sort of from a strategic or planning perspective? Does it impact how you talk to other stakeholders? I think, like, it's one thing to protect a resource for the sake of protecting it, but when you can connect it to a bigger why, it's a more impactful message. So I'm just wondering sort of your thoughts on that.
Yeah, that's a great point. Because as much as we love brook trout, you could always ask the question, it's just one species of fish. But I think the big thing about them is that they are both charismatic, so you can get more people to care about this one fish, but it's representative of a lot of things. So as we lose brook trout, we're also losing dragonflies and mayflies and stoneflies. Never going to be the poster child for conservation. But as we lose them, we lose a lot of biodiversity. We lose a lot of control of mosquito populations. We lose a lot of other things that will make life worse. So I think brook trout serve a really great poster child for conservation because they're recognizable, but they're also the indicator species. They, when they go, everything else is going to follow. So if we can keep them around, we're doing pretty good. And I will say, in terms of the advocacy aspect, certainly in talking to cities and towns, they know where their cold water streams are and they care about them.
Hey, Sean, do you have time for one last question?
Yeah.
So with respect to all the snow that we've gotten this year, are you worried that the first flush this year may be worse than others given the amount of salt, or is there a limited supply of salt that's allowed to be deployed here in Massachusetts?
There is not a limited amount. I am a little bit interested. We do have, I didn't get a chance to mention this, we do have conductivity loggers, so ways of measuring road salt being applied to streams. And I think we found, once we can actually dig ourselves out, we're going to go collect more data off of it. But I think the fact that we've actually had snow that has consistently been on the ground and not melted away immediately has kind of slowed the discharge of streams, especially the slow melt we had in the past week, does kind of space it out. And in particular, can't remember, it was 2 or 3 years ago, we had a spate of snowstorm threats that all ended up being rainstorms, but salt was applied in advance of each and every one. And so that you get a huge spike of salt right away because it's just rain. So it washes right off. So I'm hopeful that the fact that it's actually been snow and actually been, around for a while, that it helps a little bit. But certainly we are concerned about salt, and it, not just for the wildlife, because we have also seen some evidence that it's slowly increasing the sodium levels in our groundwater that feeds drinking water in places like Dedham.
Awesome. Thanks, Sean. Wonderful presentation.
Thanks.
Yeah, thank you, Sean. Thank you to you, and thank you to all the volunteers who participated in the project, and thanks for everybody for joining us today. And look forward to seeing you folks at future meetings. Thanks, everyone.
Thank
Good
you.
night.
Have a good
Bye.
night.